My name is Claudia. I'm from Asheville, North Carolina, and I'm going to be a junior this year at UNC. I want to be a chemistry mentor because I love chemistry, I love teaching, and I also love helping my peers. As a chemistry mentor, I really feel that I'm able to harness all of these passions of mine and at the same time help to make a positive impact on campus. I want to be a chemistry mentor because I have experience mentoring in the past. I was a mentor for Dr. Beaver's Chemistry 101 class this past spring, and I really enjoyed the experience, and I love being able to break down concepts for students in order to help them better understand the subject material. I'm very interested in mentoring for Organic Chemistry 1, so today I'm going to walk through a multi-step synthesis problem that may be encountered in Organic Chemistry 1 classes, and I'm going to explain how I would walk students through solving this problem. The synthesis step that I'm going to demonstrate is converting a primary alkyne, a terminal alkyne, into a primary alcohol. So the first step I would explain in going from a terminal alkyne to a primary alcohol would be reducing the alkyne to an alkene. We can do this using several different reagents. The first reagent that we could use is H2 in Lindlar's catalyst. And we could also use Na and NH3. So because this terminal carbon is attached to two hydrogens, we don't have to worry about the stereochemistry of the alkene that would result from reduction. So we could use either H2 in Lindlar's catalyst or Na and NH3. Both of these reagents would convert this into this alkene. However, these two reagents don't always result in the same product, so I would make sure to tell students about different types of problems that they could encounter and how they can use these two different reagents. So I would then explain if perhaps they were presented with this alkyne, using H2 in Lindlar's would result in a cis alkene with the methyl groups on the same side of the double bond. However, if they were to use Na and NH3, this would lead to the trans isomer with the methyl groups on the opposite side of the double bond. So now we have reduced our terminal alkyne into an alkene. And we were able to use either H2 in Lindlar's or Na and NH3. So now we must make this alkene into a primary alcohol. So in this step, it's necessary to use hydroboration of an alkene. Hydroboration is carried out using BH3 and THF on an alkene. So if I was explaining this to a student, I would want to walk through the mechanism of hydroboration. So this alkene here, we have a secondary carbon and we also have a primary carbon. This secondary carbon is more stable, carrying a positive charge than the primary carbon. Hydroboration is carried out using BH3, as I previously described. And the charges on BH3 are a little bit odd. So the boron actually has a positive charge, a partial positive charge, and the hydrogen has a partial negative charge. So because of these charges, the hydrogen is actually going to want to make a bond with the secondary carbon as opposed to the primary carbon. And the boron is going to make a bond with this primary carbon. This is called anti-Markovnikov reduced selectivity. After this step, we're then able to oxidize the compound using NaOH and H2O. This would then yield a primary alcohol, which is what we want. When explaining this, I would also caution students against using H2SO4 and H2O when attempting to make this final product, because if we used H2SO4 and H2O on this alkene, we would get this product instead of this one here. And that's a common pitfall in organic chemistry. So I would make sure to explain the pitfalls that could be encountered when completing this synthesis problem. And that's how I would explain how to go from a terminal alkyne to a primary alcohol through several synthesis steps.